Hi everyone, in this video we are going to tackle this objective. We are going to address some old Regents questions that deal with trends found on the periodic table of elements. But now let's first take a look at the trends themselves. Okay, what you see here is I wrote in red a quantity known as first ionization energy. And I wrote in green something called electronegativity, and in blue here I wrote atomic radius. Now if you recall, red means first ionization energy, which has to do with how much energy does it take to remove the outermost electron from an atom. So in other words, how much energy does it take to steal something from that atom? The green one, electronegativity, means the affinity for acquiring new electrons. So how much do I want to steal electrons from something else? And the blue atomic radius is the size of the atom, and in essence, and it's measured by putting two atoms of like elements together next to each other, attached, and measuring from one nucleus to the other and taking half of that. Now these values I put in there can be found on the reference tables and table S. So all I did was I took the values right off of table S. Here's oxygen, fluorine, and where's chlorine? Oxygen, fluorine, there it is, there's chlorine. And I just put them right in here. Now the reason why I chose oxygen, fluorine, and chlorine is because the generalized trends that we see across the periodic table are represented perfectly just with these three elements, so you don't have to memorize it. So taking a close look, we will notice that using the red, the first ionization energy, as you go to the right, ionization energy increases. So as you go to the right across a table, it goes up. And as you go up a group, first ionization energy also increases. When taking a look at the electronegativity, again, that's the ones in green. As you go to the right, once again, the electronegativity goes up. And as you go up the group, electronegativity goes up. But when we take a look at the radius, to map the increase, well, as you go to the left across the period, the radius goes up, and as you go down the group, the radius goes up. So keep that in mind as we answer these questions. Number 1. Which general trend is found in period 3 as the elements are considered in order of increasing atomic number? So period 3, let's take a look at period 3. Here is period, well, there we go. Here is period 1, period 2, period 3. Now, as you move across period 3, what happens to the perhaps atomic radius, electronegativity, atomic mass, or even first ionization energy? Now remember, it really doesn't matter that it's period 3 because we have our handy dandy, there we go, move that down. We have our handy dandy oxygen, fluorine, and chlorine. So what happens? Do we have an increase in atomic radius as we go in this direction? Atomic radius from 64 to 60? No. Do we have an increase in electronegativity? Electronegativity from 3.4 to 4.0? This one is looking good. Do we have a decrease in atomic mass? No, as you go to the right, the number of protons increases, the number of neutrons increases, so the mass increases. And do we have a decrease in first ionization energy? That's these red numbers. Does it increase or decrease as we go to the right? It increases as we go to the right. This one says decrease. So the answer for number 1 is 2. So here's question 2. Base your answer on the following question on the information below. The ionic radii of some group 2 elements are given in the table. So these are all about group 2 elements, and here they are. Here is the atomic number for each, and here is the ionic radius in picometers. The question states, state the the trend in ionic radius, as the elements in group 2 are considered in order from increasing atomic number. So, increasing atomic number. So, from 4 to 12 to 20 to 56, what is happening to these numbers? So, we do need to talk about the trend as we increase in atomic number. So, as a complete sentence, as the atomic number of group 2 elements increase, the ionic radius increases. All right, question 3. Base your answer on the following question on the elements in group 2 on the periodic table. Question says, state the general trend in first ionization energy for the elements in group 2 as these elements are considered in order from top to bottom in the group. Now, once again, I said ignore that. Just go ahead and use what we prepared on the lower right. This being right here, fluorine and chlorine. As you look straight down, what happens to the first ionization energy? And if you recall, I made those numbers in red. So what happens to the first ionization energy as you go down the group? The first ionization energy decreases as you move down group 2. So the first ionization energy, and don't abbreviate like this, I just don't have enough room, decreases as we move down group 2. So here's number 4. Which element in period 2 of the periodic table is most reactive nonmetal? So which ones are we talking about? We are talking about, let's see here, we are talking about either carbon is number 1, nitrogen is choice number 2, oxygen is choice number 3, and fluorine is choice number 4. Now you could look at electronegativity values, and the highest one would be the most reactive, but I look at this. I look at the electron configuration, and I look at which one of these is closest to satisfying the octet rule. And if that is the case, it's that close, it is going to be the most aggressive to complete the task. And what we're looking at is fluorine. Its electron configuration is 2,7. It wants very strongly to gain one extra electron. It is going to have the highest reactivity of the group 2 elements. So the answer is fluorine. And just so you know, the electronegativity is 4.0. All right, question 5. Which noble gas has the highest first ionization energy? Well, we know that group 18 elements, the ones going up and down in this column, are our noble gases. And we know that we can find our values for first ionization energy on table S. So that's table S right here. Neon is atomic number 10, and its first ionization energy is 2,000. Where was that? 2081. 2081. Argon is right down here, and it is 1521. Now, I'm not ignoring the units. It's kilojoules per mole, which is noted right here. Now, krypton, atomic number 36. Let's see if it's on this page. Yeah, there it is. Right on the bottom, krypton, 1351. You're already seeing a trend, I'm hoping. 1351. But for completeness sake, we still need to look at xenon, so we'll get rid of this one. Bring this one up. And xenon is atomic number 54. There it is. and it is 1170. So let's put that value in. Roll back to the question, and it wants the highest first ionization energy, which would then be neon, choice number 3. All right, now I love this question because it's really like a big puzzle to me. Number 6, which species does not have a noble gas electron configuration? Let's first inspect sodium plus 1. Sodium, its electron configuration is typically found right here. Okay, so that's 281. So 281. Now to be a plus 1, it needs to have lost an electron, resulting in a positive 1 charge, meaning 1 extra proton than electrons. So get rid of that, and now the electron configuration 28, it now resembles, and there it is, it resembles neon, a noble gas. So to begin with, it is not choice number 1, because choice number 1 does resemble a noble gas. All right, so let's take a look at magnesium 2+. Magnesium is right here. Its electron configuration is 282. But in order for it to become stable, or 2+, it loses these 2 electrons, and it too resembles a noble gas. All right, so AR, without a charge, AR itself, there it is. Well, it is a noble gas. So already we must think that it is choice number 4, but let's confirm. Sulfur. Sulfur is right here. Right here. Its electron configuration is 286. Looking back at the choice, it does not say that it is an ion. So the valence electron is not full. It does not have 8, does not satisfy the octet rule. So the answer is 4. It does not have an electron configuration similar to a noble gas. So this is a similar question. This is our last one. Which element attains the structure of a noble gas when it becomes a +1 ion? Again, we need to consult our periodic table. And potassium is on the left. Here it is. And its electron configuration is typically 2, 8, 8, 1. And if it lost this electron, it would result in a +1. Right then and there, there's your answer. It is number 1, but let's inspect the others just so that we could cement our thoughts here. Calcium, 2882. So 2882. For calcium to achieve its electron configuration that would then resemble a noble gas, it must lose the 2. And then it would end up with a +2. And again, the question says a +1. Now, fluorine lives on the other side. Let me move it. There's fluorine. Its electron configuration is 2-7, if you see it right here. For it to achieve its electron configuration that would be similar to neon, it would need to gain an electron, which would give it a negative charge. And inspecting choice 4, which says neon, neon itself is already a noble gas. It already is 2,8. So in order for it to achieve its noble gas configuration, it would actually have no charge. So the answer is 1.